Okay, here in Subnetting 26, we're going to show you another kind of problem that might pop up, and that is to find an invalid address. Now, in this case, we've been given a network diagram, and we have some addresses on here. We have two networks, one coming off of this node here on the router. We'll call this the .1 network. One coming off of this node on the router, we'll call that the 129 network, even though those are not actually the network addresses. But remember that the node itself has to have an address on the network. So we've got 4 addresses on this one, and 1, 2, 3, 4 addresses on this one, and we just have to find which one is the errant address. But look at this. We have here, these are /25s up here. These are /28 down here. So we've got a couple of things going on. Well, let's see if we can figure out what is happening here so we can find the errant address. So first of all, let's look at this. Now we've been given only the last octet here of these addresses because this is a /25. And because this is a /25, it's occurring up here in the 4th octet. So they've only given us the 4th octet here to deal with. But let's, just to make this a little easier, let's go ahead and put in some of the others. I'm going to put in 192.168.156.0, and we'll start there. Now we know that the /25s, which we have here, the increments are 128s. Increments are 128. So let's go ahead and increment this by 128. 192.168.156.128. So remember, this is in the 4th octet. So we're incrementing in the 4th octet. What would the next one be? Well, it would be 192.168. Well, if we go here, if we double this again or add another 128, we get to 256. So that we can't have a 256. We're going to have to roll this one up. 157.0 and then 192.168.157.128. Okay, that should be enough to get us going on that one. Let's take a look at this bottom one and see what we have. This is a /28. So now we're incrementing by 16s. All right, let's see what we have here. We have a 129, a 133. Well, we're already quite a ways up there. In fact, all of these are above 128s. So remember my rule that said I can jump ahead. Remember now that because I'm incrementing, this is 28s, so I'm incrementing by 16 in the 4th octet, I can just jump ahead here since they're all 129 and higher, and I can start with 128. So let's do that. 192.168.156.128. We know that that's a valid network address because it's one of them in this series. If we combine these in any way we want to, as long as it's above the /8, right? 28. I'm sorry, 16. We're doing by 16s. I should mark that so I don't get lost. So by 16s in the 4th octet. All right. So as long as we're staying in these and doing any combination of them that we want in these hosts, we can jump ahead and then go by 16s after that. Again, /28. So we're incrementing 16 in the 4th octet. 192.168.156. Now we have to add 16. So let's see, what is that? 128 plus 16, 8, 14, 2, 3, 4, 144 would be next. And we don't have any higher than 144. So it looks like I have all the information I need here to figure this out. All right, now let's start looking at these and see if we can figure out what's going on. Well, .1 is certainly a valid address because if this is the network address, .1 would be the host address. So this one is a host address. In fact, just for fun, let's go down like this, and let's say .1 is a valid host. How about .127? Is that a valid address? .127. Well, if .128 is a network address, then .127 would be a broadcast address. And we have already discovered the problem right here. We know that that is a broadcast address and that is not allowed. So B would be the correct answer in this case. Well, just for fun, just to make sure that we haven't made a mistake, let's go ahead and look at the rest of these. .30, let's got to change that back to black. .30, is that a valid address? Well, yeah. .0, .128, so yeah, .30 would be somewhere on the 0 network, so that is a valid host. And .118, is that a valid host? Yes, again, we're between 0 and 128, actually between 1 and 127. 126 is the last valid host address. So this 118 certainly is a valid host address. Now let's look at the other side here. .129 is, oops, 1.129. Is that valid on this set of addresses? .129, yeah, 128 is the network address, so 129 is the first valid host address that we have on that network. How about 133? Well, 133 falls way between here, 128 and 144, so yes, that's a valid host address. 130. Well, again, 130, well between the 129 and the 142, right? 143 is the broadcast, 142 would be the last valid host. So yes, that's a valid host. And finally, the .139, again, 139, well between these two, so that is a valid host. So we were correct the first time. We could have stopped way back here, but this one is an incorrectly configured address because that is the broadcast address for the 192.168.156.0 network. Since the next network is .127 or .128, the broadcast address is .127, the one just before the next network address. So there you have it. Now again, I've done this without my exhaustive table. It makes it a little quicker. Of course, it took me more time to type them than it would take you to just jot them down or look at them or jot these down and quickly compare. But you get the idea. I hope you get the idea. And again, I had to start and notice, first of all, that these were completely different subnet masks here. And so the increments were different for each one of these things. All right, thank you for watching, and we'll see you in Subnetting video 27.